What is Near Protocol? If you're into the blockchain world already, you would know this. And if you're not, you should know this. Popular networks like Ethereum and Bitcoin aren't scalable. If millions of users were to use these networks, the transaction speed would be too slow. The transaction fees would be too high. And most importantly, the computational energy requirements would just be environmentally unsustainable. Focusing on this issue of scalability, there are quite a few blockchain alternatives that have emerged. One of the blockchain alternatives that caught my eye is Near, which calls itself an infinitely scalable blockchain network. Can blockchain networks really be infinitely scalable? Let's find out. Incidentally, there is very limited information available for Near Protocol online, apart from its own resources, which can get quite confusing. So we thought of covering this topic for you so you can decide for yourself if its technology could be a game changer in the blockchain. Welcome to Crypto Skills, the channel that makes all the complicated crypto topics easy to understand. Make sure you stay until the end, since you're going to learn more about complex but awesome technologies, radically simplified with easy to understand examples. And if you understand and ultimately go on to believe in Near Protocol, its Near token could be an excellent multi-bagger investment opportunity for you. Let's begin. What exactly is Near Protocol? Near Protocol was founded by two co-founders, Alex Skidanoff and Ilya Polosukin. It powers Near, a relatively new blockchain launched in 2020. Near is a smart contract-enabled platform, just like Ethereum, where developers can create and launch decentralized applications, dApps. Think of it as a cloud-based data storage system like Microsoft Azure and Amazon Web Services that serves as the base layer on which applications are built. If you are a non-tech person and don't understand what that means, don't worry. It's pretty simple. Your favorite applications, like Netflix, for example, have a huge volume of data, like codes, content, and user data. This ordinarily requires you to maintain physical servers and build infrastructure around them. Service providers like Microsoft Azure and Amazon Web Services allows applications to be deployed to the cloud without needing them to maintain the physical infrastructure. Near operates similarly. It serves as the base layer on which decentralized applications are built. But rather than being run by a single entity like Amazon and Microsoft in the case of AWS or Azure, Near is operated and maintained by a distributed network of computers. Near Protocol uses a native token called Near, which allows users to pay fees for transactions, run applications, and pay for storage. If you haven't figured it out yet, Ethereum does kind of the same stuff, and Ethereum has the largest community of developers to build dApps. So, why Near? For starters, the Ethereum network is plagued by delayed updates, congestion, and high fees. As we discussed at the beginning of this video, Ethereum is fundamentally not scalable on account of high transaction fees and low transaction speed. So even if I build a kick-ass decentralized application that attracts hundreds of millions of users, if it's built on Ethereum, it'll probably be slow and really hard to scale. Near, on the other hand, uses a proof-of-stake consensus mechanism, which is faster and cheaper and therefore scalable. This scalability is useful for developers building dApps on it. So, what makes it more scalable? Three important technologies make Near Protocol scalable. The first is its consensus mechanism. The blockchain is fundamentally decentralized and therefore requires a consensus mechanism where the participants contribute to the verification and authentication of transactions occurring on the blockchain. This is basically how new transactions are added to a blockchain, and this technology decides how scalable the blockchain will be. If you don't know it already, Bitcoin and Ethereum use a proof-of-work consensus mechanism where miners compete among themselves to add transactions onto the blockchain. This requires more computational energy, is slower, and has higher fees. In the proof-of-stake, the protocol chooses validators to confirm blocks of transactions. How does it choose who will be the validator, though? Well, the participants pledge their coins with the protocol. From those participants, the protocol chooses validators to confirm blocks of transactions. The more coins pledged, the higher is the chance to be chosen as a validator. This can make it quite expensive to become a validator. What if you don't have sufficient coins? Near blockchain uses a delegated proof-of-stake consensus mechanism. So this means that if you don't have the resources to participate in the process of validation, you can lend your coins to someone who can. Since proof of stake doesn't involve solving complex problems like proof of work, it takes less time to add blocks onto the blockchain. Therefore, delegated proof of stake is more scalable. The second technology that makes Near scalable is its block production technique. Doomslug is Near Protocol's new block production technique. Although it sounds a little technical, hang on, I'll simplify this. As you know, blockchain is a chain of blocks. Various techniques determine how the blocks are added onto the chain. But in any technique, the most fundamental condition to add a particular block is that the previous block needs to be final before the next block can be added to the chain. Makes sense, right? Usually, 2 rounds of communication between computers on the network gives finality to a block. This is called BFT finality. BFT stands for Byzantine fault tolerance. Now, before you doze off completely, let me tell you that its meaning is not as difficult as its name. The blockchain is a decentralized network that depends not on a single server, but on the number of computers to process the transactions. BFT essentially ensures that the blockchain does not crash, even when a particular computer or several computers are faulty. So, once the block gets the BFT finality, it is irreversible. Only then the next block can be added to the chain. In a Doomslug technique, BFT finality is achieved after 2 rounds of communication between the computers. So what makes it special? Well, in the Doomslug technique, the practical finality, called Doomslug finality, is achieved after only 1 round of communication. Once the Doomslug finality is achieved, the next block can be added to the chain. Therefore, the Doomslug technique finalizes twice as many blocks as other techniques over a period of time. Consequently, its throughput is higher. The more the throughput, the faster the blockchain, and the greater its scalability. The third unique technology that makes Near Protocol infinitely scalable is its sharding mechanism. The main reason for Ethereum's low throughput is that every node, which is a fancy word for a computer, needs to process every single transaction. In the sharding mechanism, however, the work is split among all the participating nodes. The Near adopts this sharding mechanism. Its particular sharding mechanism is called Nightshade. Cool name, right? How does it work, though? Although it is very interesting, it goes on to become a little jargony. So let's make it easier to understand with an example instead. You can imagine Ethereum as a store with a single checkout line. Every transaction needs to be processed through that long checkout line, which makes it annoyingly slow. Near, on the other hand, is a store with multiple checkout lines. Therefore, transactions on the blockchain have more roads to travel down to be approved to increase the throughput and decrease congestion. This sharding technology of Near, called Nightshade, has many cool features though. For example, it plans to expand the criteria of who can be a validator so that you can participate in the network even with your smartphone. You won't need to have any specialized hardware to validate the transaction, which is normally the case in other blockchains. In our example, even you can become a cashier at the Near store without needing any special equipment. You will be able to earn Near tokens for validating the blocks of a specific shard, paving the way for anyone, anywhere, to help secure the network. Also, Near plans to introduce a dynamic splitting and merging of shards based on their requirements. In other words, more checker lines will be able to open automatically as needed to decrease latency and increase throughput. Now that you see an apparent technological advantage, let's see how it compares to other blockchains. The scalability of blockchain is often compared on its TPS, or transactions per second. At present, Ethereum can process approximately 15 transactions per second, and Bitcoin processes only approximately 7 transactions per second. As compared to a centralized network like Visa, that is shockingly low. The Visa network handles around 1,700 transactions per second, although Visa claims it can handle a whopping 24,000 transactions per second if there is a need someday. Pretty huge, right? Wait till you hear about the Near protocol's TPS. Once all the phases of Near protocol are fully implemented, one shard will be capable of 2,500 to 3,000 transactions per second. However, as a blockchain, Near can scale infinitely by increasing the number of shards to support the rising number of users. Therefore, Near's nightshade is theoretically limitless and can handle millions of transactions per second. Alright then, if you watched to this point, you know more about blockchain technologies than most. If you have enjoyed our video so far, please like it. It makes us feel appreciated for all the hard work we are putting into making videos. Okay, so next up, I want to explain to you an important application on Near called Aurora. So as you know, the Ethereum blockchain has been around for a long time, and many developers have already built decentralized applications on Ethereum platform, whereas Near has launched only recently. Given that Near has so many advantages over Ethereum, the developer may want to use the Near platform, but the task of developing a D-app on the Near platform can be a complex one. Well, no more, thanks to Aurora. Aurora is an Ethereum virtual machine built on Near. It helps developers to run their Ethereum D-apps on the Near platform. Essentially, what this means is that the existing D-app codes can be copied, pasted, and run onto Near with Aurora. I believe that this is critical to the success of Near. Since the developer community doesn't need to learn any new coding language or develop apps from scratch for Near, it will result in faster adoption of the Near protocol. These features and mechanisms make Near protocol a special crypto platform, making it stand out from the crowd. To me, Near definitely seems to have a bright future. But I would like to know more from you. Will Near attract even more D-apps than Ethereum? Does the infinitely scalable claim appear too good to be true, or does its technology make sense? If you enjoy this video, please hit the like button to show your appreciation for our efforts, and consider subscribing so you don't miss our next bite-sized explainer video on crypto. I'll see you in the next video. Take care.